Okay guys, so today we're going to talk about triangles, the three-sided polygon. But before we do that, we need to establish some rules to this game moving forward. Okay? There are certain things that we need to know when we're talking about polygons in general and triangles more specifically. There are a few things that we can assume. One, we may assume that lines are straight, and if two lines intersect, they intersect at one point. So, if you see a line anywhere, if you see a line anywhere, you can assume that that line is straight. And if you see two lines intersecting, you can assume that they are in fact intersecting at just one point. Okay, so here we have a line, and if you see a line, you can assume it's straight. And if you see two lines intersecting, you can assume that they intersect at this one point here. Second, you may assume that the points on a line are collinear, meaning that the points are on the line and that all points shown in the diagram are coplanar, meaning that they are all on the same plane. So if you see a line and it has dots on it, you can assume that all the dots are on the line and that all the dots are coplanar. Now, that being said, there are some things that we cannot assume, and these are probably a little bit more dangerous than the things that we can assume. I'm sure you've heard the expression about what happens when you assume. First, let's take a look here at the things that we can not assume. One, you may not assume that just because two lines or segments look parallel, that they are parallel. They must be marked parallel. And if you remember, we discussed when we talked about lines, the rules for marking parallel lines. They have to have those double red arrows. Second, you may not assume that two lines are perpendicular just because they look perpendicular. They must be marked perpendicular. And again, when we talked about lines, we showed lines that were perpendicular. They made right angles with a little red box and 90 degrees. And finally, if you have pairs of angles, segments, or polygons, they are not necessarily congruent. They don't necessarily match unless they are marked with information that tells you that they must be congruent. So you can't go by what you see, you can only go by what you prove. So let's look at some examples where they ask us to show which lines are perpendicular, which lines are parallel, and which pair of triangles are corresponding. Okay, so let's answer the first question. Which pair of lines are perpendicular? So if we look here, I have four lines which are intersecting, and two of them are perpendicular. How do I know they're perpendicular? Well, they're creating a right angle right here. So I can say that, I can see here that line JK and line JM are the lines that are intersecting that are creating that right angle. So my response would be that line JK is perpendicular to line JM. And remember that special notation we talked about showing how lines are perpendicular. Next, the second question asks, which pair of lines are parallel? Well, if you look here, all the lines look as if they're parallel. They're all leaning in the same direction, and they all look like they're, like they'll never touch. But again, we can't go by what we can see. We can only go by what we can prove. And the only two lines that have the double red arrows necessary to prove that they're parallel are these two right here. So if you remember, my special notation would say that line AB is parallel to line CD. Finally, let's answer the last question. Which pair of triangles is congruent? Here you notice I have three triangles. And if you guess that these two here are the ones that are congruent, you are correct. However, let's pay close attention to how they're named when we name the triangles. Let's see how they are named. We would say then that triangle STU is congruent to triangle XYZ. STU is congruent to XYZ. And you might say, well, Mr. C, that's pretty simple enough. You're just going in alphabetical order. That's not true. That's not true. Let's look at these triangles a little bit closer. If I look at angle S, you'll notice that I only have one congruency dash there. Well, which one here has one congruency dash? Is it X? Is it Y? Is it Z? It's X. So S matches X. Then, if we look here, which one has two congruency marks? Well, let me not say angle T, vertex T, because we can't call that angle T. The vertex is being shared. I can call this angle S because it's not being shared, but I can't call this angle T. So I would say vertex T has two congruency dashes, and angle Y, or vertex Y, has two congruency dashes. And notice those two match. And finally, well, I have vertex U and vertex Z, or angle Z. They both have three congruency dashes. And you notice that they match in the order. S matches X, T matches Y, and U matches Z. So triangle STU is congruent to triangle XYZ. Next, let's talk about special kinds of triangles. The same way we had just special kinds of angles, we also have special kinds of triangles. The first kind of special triangle is a right triangle, which I'm sure you've probably seen before. And a right triangle is a triangle that has one 90-degree angle. All it takes is one 90-degree angle to make a triangle a right triangle. If you notice here, this triangle has a 90-degree angle here, and this one has the indication of a 90-degree angle there, and this is considered a right triangle. Next, well, if you remember, there are also other kinds of angles, so yeah, we have other kinds of triangles. Here I have an acute triangle, and in an acute triangle, all of the angles measure less than 90 degrees. If you remember, an acute angle is an angle that measures from 0 to 90, or less than 90. Well, in an acute triangle, all of the angles measure less than 90 degrees. And if you're thinking about that other special angle that we talked about and wondering if that applies to triangles, you are absolutely correct. Because now we also have obtuse triangles. We also have obtuse triangles. And in obtuse triangles, the triangle has one angle which is more than 90 degrees, which is an obtuse angle. So if you notice here, this triangle has one obtuse angle, and this triangle here has one obtuse, so they are both considered obtuse triangles because one angle is more than 90 degrees. Now that we're done with all the angles of special triangles, let's talk about some of the sides of the special triangles. This here, ladies and gentlemen, is called a scalene triangle. And in a scalene triangle, none of the sides are equal. None of the sides are equal. No sides are equal whatsoever. They are all different sizes. Now, the opposite of a scalene triangle is an equilateral triangle. Equal meaning equal, lateral meaning sides, and if all the sides are equal, then you have an equilateral triangle. Here is denoted or shown by the congruency marks. And here we have numbers, so we can show all sides are equal either via congruency marks, or we can show that all sides are equal via number measurements. Next, moving right along down the list, we have an isosceles triangle. We have an isosceles triangle. And an isosceles triangle is a triangle in which only two sides are equal. In which, well, let me not say only, but in which two sides are equal. So if you notice here, this triangle here has two sides equal. This one has two. This one has two. And wait a minute, but Mr. C, isn't that an equilateral triangle because all three sides are equal? Well, yes, it is. But an equilateral triangle is also an isosceles triangle because at least two of its sides are the same. And that's a trick question that you need to watch out for. So if all the sides are equal, it is equilateral. And the only triangle that can be both equilateral and isosceles is an equilateral triangle. Now, there are some special details that we need to pay attention to when we're talking about equilateral triangles. Okay? In an equilateral triangle, you will find that yes, two of the sides are equal. only two of the sides are equal. Well, these two angles down at the bottom are called base angles. They are called base angles, and they lie on the base of the triangle. And directly across from the base is called the vertex angle. Remember that these points on a triangle, whatever they may be called, are actually called vertices or vertexes, if you want to say it incorrectly, right? But the one that is directly across from the base, if you take the base and you kick a little arrow straight into it, that is called the vertex angle. It is across from the base angles. It is across from the base angles. Okay? And I know that's a lot of information on triangles, but now that we have that, let's try some problems together.